Hello everybody, and welcome to page 137 of the workbook. And on this page we're going to be talking about some alternate notations for partial derivatives. We'd like to get started calculating these, and it's going to be convenient to have some alternate ways of writing them down. Okay, so we'll start ourselves off here with a function of two variables, z equals f of x and y, and we'll start with the first row of this table here, fx. Recall that notation we already saw in a previous example. It just means the partial derivative of f with respect to x. What I want to share with you here is another way of writing that down. We could also write that same derivative like this. This is going to look a little strange the first time you see it. You might be wondering, what is this strange symbol here that looks kind of like a 2? Well, we would read that as partial. So in words, partial z, partial x is what I just wrote down. Okay, in particular, that symbol, when you see it, you would read it off as partial. Okay, and then partial z, partial x in words. Let's write that down. And all that means is the derivative of z with respect to x. It's meant to kind of remind you of the calculus 1 notation that looked like this. dy dx meant derivative of y with respect to x. That's the same idea for partial z, partial x. We use a new symbol just to remind ourselves that we're doing a partial and not an ordinary derivative. Okay, we could do the same thing with fy. We could write that as partial z, partial y. That means the same thing as the derivative in the y direction. Okay, and just kind of one alternate way of representing both of these two derivatives that we already looked at, partial z, partial x, we could also write as partial x of our function. And down here, partial y of our function. Okay, means the same thing. And so what we've got so far in our table are first derivatives. We started with a function z equals f of xy and took the derivative with respect to both of the input variables. Okay, but we can take second partial derivatives as well, and that's kind of what we're looking at, okay, in the last 4 rows of our table down here. Okay, notice that there are 4 of them because we've got 2 input variables. So if we start with the first line here, fxx, it's like we're starting with the derivative with respect to x, and we're going to take the derivative again with respect to x. Okay, so we could write that as just fxx if we wanted to. And that's just like saying we're going to start with the partial derivative of z with respect to x, and we're going to take its derivative one more time with respect to x. Okay, and then similarly for fyy, we take the derivative of f with respect to y twice. We would start with the derivative of z with respect to y, and then we just take the derivative with respect to y again. Okay, and then we come to the last 2 rows. These are what are known as the mixed partials, because we're taking the derivative with respect to one variable and then with respect to the other one. Okay, so f of xy is like saying that we're going to start by taking the derivative of z with respect to x, okay, because the x is the variable that comes first here, and then we're going to take the derivative of that derivative with respect to y. Okay, so using the partial notation, that derivative would look like this. Okay, and the other way around, fyx, we'd be first taking the derivative of z with respect to y, and then after we have that derivative, we'd be taking the derivative with respect to x. Okay, and so those last 4 things on our table here, we would call the second derivatives of this function. Okay, and in the future examples we'll get started talking about how we would calculate these partial derivatives if we had a formula for our function.